What's up? Alright, so it's Investigation 2-2. We're looking at cicada cycles. In case you didn't know what a cicada was, it is this guy right here. They're disgusting bugs that come out at different years. And for this example, you're going to have to use your imagination. You're going to have to pretend that you are a farmer and that you are excited about killing cicadas with some pesticide because they are coming to eat all of your crops. So cicadas emerge at certain years. So the big question is, how can you use the least common multiple to predict things and to figure out answers? How can you use the least common multiple of two numbers? So two numbers is what we're looking at. 2-2, cicada cycles. Let's go. So you're a farmer who deals with orchards. You know that in your region there are two groups of cicadas. One group comes out every 8 years and the other comes out every 12 years. They come out to lay eggs and then they basically die. And we're going to say that in year 2000 was the first year, and farmers want to plan ahead by purchasing insecticides. So these are really farmers that really like to be ahead of things. In what years should the farmers order a standard amount of insecticide that kills insects? In what years should they order a double? Now, the regular years would be all the regular years, and the double would be when the years match up, right? So here we go. So I'm not going to have you write in the years, okay, until we find the ones that match. What we're going to do is we're going to write multiples of 8 across the top. So it's going to be 8, 16, 24, 32, 40. I'm sure somebody will let me know if I do this wrong. Yes. 54, 8 times 9, 8. That's not right. 54. Somebody has 48. Let me make sure. Sorry, it's 56. My bad. My dyslexia. It's good to see a teacher make mistakes. It shows that we are human. I am definitely human. I make a lot of mistakes. I am nothing close to perfect. And then we're going to skip count by 12s, right? So 12, 24, 36, 48, 60, 72, 84, 96, 108, and 120. Okay, so now these are going to go blank because these are going to be the same thing. This is 8, 2008, 16, 2016, 24, 2024. We're going to highlight the ones that are the same. And so as I'm going, I'm comparing. I can see that 24 works and 24. I can see that 48 and 48 work. Okay, and I can start seeing a pattern, right? You'll start noticing a pattern, right? It's going to go 1, 2, multiple, 1, 2, multiple, 1, 2, multiple. So we're going to start seeing this pattern emerge mathematically, and if we highlight it, you can see that every other year they line up. So which years should they get a standard amount? Well, every year should be a standard amount, so don't worry about that one. What about a double one? The doubles would be in 2024. The doubles would be in 2048. And the doubles would be in 2072. And we did that just by finding the ones that share. So we listed all the multiples and we highlighted the ones that they had in common. So here's the one in common here. Let me see if I can make this a little bit more clear for you guys. And you can see, you'll start noticing the pattern, right? There you go. I keep having to pause the video to move around. So why does it not make sense to use factors? Remember, factors are two numbers that are multiplied together to make a product or a multiple, like 8 times 2, 8 times 3, 8 times 4, 8 and 3 would be the factors. Well, factors are equal to or smaller than the number, and the multiples go up. These are common multiples, 24, 48, 72. 24 happens to be the lowest multiple, which means it's the next occurring. The most recent year will be 2024 when the cicadas come. Did you notice any patterns with it? Yeah, I noticed we went 1, 2, right? For the 8s, 1, 2, 1, 2. And for the other ones, it went every other one. So 12, 24, 36. So for the group Bs, it was every other year. And how could you use LCM to find every year if you wanted to do that? Well, once we know 1, we just have to say this is the first time it occurred, the second time, the third time, and you can say it's 1 times 24. Sorry, it's a lie. 2 times 24, 3 times 24, 4 times 24. Once we know the LCM, we should be able to find every year. So down here, talking about packages of hot dog buns, I want you to imagine that hot dogs, okay, I can't write this far over you guys. 8 in a pack, and buns are 10 in a pack. Okay, so now we have 8 and 10 in a pack, and I'm going to show you a different way to solve this. So we're going to write 8 and 10, and we're going to have this little thing come down. What times what is 8? Well, 2 times 4, and then 2 times 2. I'm going to circle the stuff they have in common. And for 10, it's just 2 times 5. I circle those. Now I'm going to write the numbers 8 and 10 here. What numbers do 8 and 10 share? Those go in the middle. What do they share? They share a 2 and a 2. So I put that on the inside. Do they share any other numbers? No, they don't. So I'm going to put the other 2's that the 8 has over here. And then I'm going to take the 5 and put it with the 10. Now I just multiply straight across. So the GCF is right here. GCF is 2. But now I'm going to multiply all these numbers to get the LCM. So it's going to be 2 times 2 is 4, times 2 is 8, and 8 times 5 is 40. Okay, so that's a quicker way of doing it if you have big numbers. If you didn't have the time to do this, or if it was a little bit confusing, you could have just listed out all the multiples of 8. So it would be 8, 16, 24, 32, and 40. And then for 10, it would be 10, 20, 30, and 40. And you would have seen that there, right? Now some of you might get confused. The question is, how many hot dog packages do you need to buy? That's what they're going to say, because you're going to think the answer is 40. You got to buy 40 hot dogs. Well, in actuality, because there's 8 in a pack, you have to buy 5 packs of hot dogs. And then for the buns, 10 come in the pack, you'd have to buy 4 packages of buns. Okay, jump to the back. Steve's grandfather said cicadas sometimes damage his orchard. One year there were so many cicadas they wrecked all the buds of his young trees. Both the 13-year and 17-year cicadas came up that year. So now they just changed it. Same question, different numbers. This is just practice. Don't get caught up in it. We're going to list all the multiples that we can all the way through until we hit the end. So it'll be 13, 26, right? 17. 34. So go ahead and use your calculator, right? Like me. And just type in 26 plus 13 is 39. Plus 13 is 52. And keep going until you get all those. And then do the 17s, right? 17 plus 17 is 34. Plus 17 is 51. And we're going to list all the way through to the end there. So go ahead and do that. Pause the video, do that, and I'll come back on with some of the answers. Okay, so there I'm done writing all mine, and now I'm going to look for numbers that they have in common. So as I'm going through, I'm looking for 52, 51, 60. It's close, but man, it's not. I don't see anything, and then all of a sudden I see 221. And with 221, that is going to be the lowest common multiple. So the year 2221 is a year that the 13-year and the 17-year cicadas will come out. And you figure this out by listing out all the multiples. We could do it the other way, right? If you had 1 and 13, if you went out and did the Venn diagram, you could figure out that way. Okay, down here you have a lot of work to do. A lot of work. But guess what? You don't need to do that one. That one will be very difficult. So really analyze this. How did you figure it out? We listed the multiples, right? We listed the multiples. Okay, I'm going to write that in, and then I'm going to come down here and take a look at these questions down here. We will do this one. I just want to do it as a class. I don't want to do it as, we're actually going to do this one today when we come back. So I want to do this one as a class because this one's pretty difficult. So we'll answer that. Down here, Stephen developed a method. The next time 2 cicadas appear, he says that if you multiply the cycles together, so we're talking about this one, if you multiply 13 times 17, so yeah, he talks about multiplying these two together, 13 times 17. And that would work in this case because these are prime. And so yeah, you would get 221. If you multiply 13 times 17, it would work there. But if I multiplied 12, 14, and 16 together, no way. It's going to be a huge number. It's going to be like 688 or something like that. So does it work every time? No. Because it gets you a multiple, a common multiple, but it doesn't get you the lowest one. If you look back to here, 8 times 12, right, that is what? Like 80? 96. And 96 is a multiple, but it's not the lowest one. It's not even like the third lowest. It's the fourth lowest. So yeah, it doesn't work every time because it doesn't give you the lowest one. It'll give you a multiple, but not the lowest one. And then down here, we'll take care of this when we get back. So that's the lesson for today. That's 2.2. This one we're going to fill out together, and that should be it for the math. All right, guys, talk to you in a little bit.